In this video, we'll discuss how microcontrollers help reduce development time in embedded firmware development. Let's explain this concept with the example of human body. Think of how human brain works. In embedded system, a microcontrollers act as a brain. Its embedded firmware contains instructions for decision making and actions. Imagine picking up a cup of coffee. The eyes see the coffee. The brain registers the desire to drink it. The brain processes these desires and builds a series of actions. The brain sends instructions to extend the hand and grab the cup of coffee and bring it close to the lips. In embedded systems, this is similar to how firmware defines responses. For instance, if a sensor detects an input that exceeds a threshold, the microcontroller performs the necessary action based on predefined instructions in its firmware. Firmware is a critical component of any embedded system, enabling efficient and intelligent device functionalities. Now, let's explore how microcontrollers simplify and accelerate firmware development. Modern microcontrollers offer a range of features and tools that help embedded engineers reduce development times. Here is how. The microcontrollers come with a ton of pre-built peripherals like ADC, UART, SPI, I2C, CAN, LIN, PWM, timers, and GPIOs. These peripherals eliminate the need of separate chips, streamlining the hardware design. Comprehensive software development kits or SDKs are provided by the manufacturers with pre-written libraries and drivers, allowing firmware developers to focus on application logic rather than lower-level hardware interactions. Semiconductor companies like NXP, Renesas, Microchip, and STM offers evaluation boards or EVPs. These boards simplify hardware development by providing easy-to-access pins and peripherals. Pre-written bootloaders eliminate the need of developing one from scratch, saving significant time. The microcontroller ecosystems come with dedicated IDEs or integrated development environments such as CS+, S32 Design Studio, Keel, ESP-IDF or STM32Cube IDE. These IDEs offer code compilers, debugging tools, simulators, pre-written templates and projects. Such features streamline code development, testing and debugging. Many microcontrollers support real-time operating systems like FreeRTOS, Zephyr and RTX. Real-time operating systems simplify multitasking, making complex application development faster and more efficient. Manufacturers provide well-documented reference manuals, datasheets, and application notes. Additionally, active developer communities help resolve issues quickly and reduce learning time. Many microcontrollers integrate advanced features like power management and sensor interfaces. These reduce the need for external components, simplifying hardware and firmware designs. Tools like E2 Emulator, J-Link, and ST-Links allow real-time debugging. Built-in debugging interfaces like SWD and JTAG enable efficient debugging. Some evaluation boards also come with integrated debugging interfaces. Microcontrollers are invaluable for reducing development time for embedded firmware. From pre-integrated peripherals to powerful development tools, they simplify and accelerate the process, enabling engineers to focus on innovation and application-specific solutions.